Hi, everybody. So this is going to be, now we're done with Earth's interior, and we're moving on to the next section of our notes. Okay, and the next section of our notes, what we're doing is we're talking about Earth's plates. And the reason we do that is because I want you guys to know what causes mountains to be built, what causes volcanoes, what causes earthquakes. So this is now, we're now into plate tectonics. Okay, so the reason we started with Earth's interior is because I wanted you guys to know what part of Earth's interior is a plate. So the part of Earth's interior that is a plate is called the lithosphere. And remember, the lithosphere is all of the crust in the very upper mantle that moves as one big slab. And the biggest plate out there is called the Pacific plate. And they move about the same speed that your fingernails grow. So anywhere between 3 and 8 centimeters per year. If you didn't cut your fingernails, they'd be about 2, 3, 4 inches long by the end of the year. So that gets you anywhere between 1, 2, 3 inches per year. Okay, that just gives you an idea. Okay, and how do they move? They move by convection, and we'll get to that later. This is an illustration that shows you all of Earth's plates. Okay, and every single line here that you see is called a plate boundary. And the plate boundaries are where one plate begins and one plate ends. So this plate boundary right here represents where the Pacific plate meets the Australian plate. And this is a really important boundary right here. This is the Pacific plate out here. And this boundary line right there is where the Pacific plate meets the North American plate. And these boundary lines are called faults. Okay? And a fault is just an area on Earth where movement may occur. So this fault right here is one of the most devastating faults there is, one of the most devastating plate boundaries. It's out in California, okay, and this is the San Andreas Fault. This is an 1,800-mile stretch where movement occurs. And what's happening is the Pacific plate is moving northwest. And so is the North American plate. It's moving northwest, but much, much slower. So California is split in half by the San Andreas. And Southern Cal, like LA, is moving northwest and will someday be at the same place that San Francisco's at. So if it came back to Earth in about 100 million years, LA and San Francisco will be neighbors. And then about another 100 million years, LA, which is enjoying nice weather right now in the southwestern part of the United States where it's nice and warm, will be way up here by Alaska. Not something that you and I are going to have to worry about, but hundreds of millions of years from now. Okay, literally hundreds of millions of years. So we're going to talk about all the plate interactions that can occur today. Okay, so this was first observed by the most famous person to deal with plate tectonics is Alfred Wegener, and he was the first person who came up with the idea that at one time all continents were combined together in one big massive continent, and he called that continent Pangea. All right, and this is Wegener right here. That's actually a hat he's wearing. Okay, that's not his hair. So just you should laugh a lot about that. But this was his drawing of what Pangea looked like. And what we're going to do is we're going to come back and take a look at his evidence in the future about how he kind of came up with this theory. And if we were in class together, we'd have a lot more time to do this, but we just don't have the time. So this is just his evidence right here, so we're not going to worry about this evidence right now. Instead, we're going to get into plate interactions. Okay, so that begins, you'll see right here, plate boundaries and faults. That's where we're going to be in your notes now. Okay, so once again, a plate boundary is where two plates come together, and a fault, I'm just going to define that for you, is an area on Earth where movement occurs. Okay, where movement occurs. Probably spelled that wrong. Nope, I didn't. Where movement occurs. Okay, so that's what a fault is. And a fault is where two plates come together. And I'll leave that, and what I'm going to do is I'm going to leave these notes for you guys. I will leave them in Google Classwork, or excuse me, Google Classroom classwork, so that you guys can alter this and see it. So the first type of boundary we're going to talk about is called a divergent boundary. A divergent boundary is where when two plates come together, and instead of the two plates coming together or sliding past one another, they're splitting apart. So this is where two plates move away from each other. And so I like to draw it in class even. I like to go like this. So that's what the two plates are doing, diverge. At divergent boundaries, you are going to have volcanoes. You're also going to have earthquakes. Okay, so that's really important. Most of Earth's divergent boundaries are located underwater. Okay, so most are located underwater at the bottom of the ocean. In total, there are, I think, 14,000 miles of divergent boundary on Earth. The other thing you should know about divergent boundaries is this is where new crust is created. Okay, so we're making new crust. Usually it's oceanic. And once again, at divergent boundaries, you're going to have volcanoes and earthquakes. All right, so that new crust is made at volcanoes. And because plates are moving, that's going to cause an earthquake. So real examples of divergent boundaries on Earth are like the Mid-Atlantic Rift. Okay, Iceland is a real example of a divergent boundary at the surface of the Earth. The Juan de Fuca Rift, the Rift Valley, the Southeast and Southwest Indian Rift, the East Pacific Rise. Notice these terms that go with it. Okay, whenever you hear the term Mid-Atlantic Rift, also goes by the term ridge. Whenever you hear of the term rift, ridge, or rise, these are the landforms associated with a divergent boundary. So I'm just going to write here so you know. Okay, rift, ridge, or rise. These are the landforms where a divergent boundary. All right, where there is a divergent boundary. Okay, so those are the landforms associated with them. And that's really all we have to say about divergent for right now. The next thing we're going to do is you're going to get a plates map, and you're going to have to show me some examples of divergent boundaries, okay, where plates are moving away from each other. It's going to be a little tricky, but before we get to that, that won't be for a few weeks yet. Convergent boundary, you guessed it, converge, okay? So that's where two plates are coming together. So I'll just go like that, and then, oops, like that, okay? So two plates are coming together. Unlike a divergent boundary is where new crust is created, okay? Convergent boundary is where crust is destroyed. The Earth never gets bigger, never gets smaller. So if crust is created at one place, it's going to be destroyed at another place. That's not destroyed, it's destroyed. There we go. Okay. Major earthquakes and volcanoes are common. It all depends upon what type of convergent boundary. Because there's two different types of crust on the Earth, if you remember. There's continental crust, which is made of granite. It's low density. And there's oceanic crust that is high density, that's thin, and it's made of basalt. So two different types of crust can always come together, okay? So there's three types of ways that we have convergent boundary. There is a continental type of convergent boundary. That means two continental plates are going to collide, okay? They're both low density. And what's going to happen there is when two continental plates collide, you're going to get non-volcanic mountains, okay? So you're going to get tons of mountains, but they're not going to be volcanic. You're going to get major earthquakes. And the Himalayas and Appalachians are real examples on Earth where that has happened. Okay, so these are examples of continental. But because both types of crust are low density, when they hit each other, all right, what's going to happen is they're both going to go up. It was hard for me to find an image of this, but I think I have it later in your notes anyway. Then there's a continental oceanic, CO, all right? Continental's real low density, oceanic is real high density. So you've got two unequal density plates coming together. So think about what happens if they're not of equal density, all right? When you have two things that are not of the same density, one's going to go up and one's going to go down, kind of, sort of, all right? So in this situation, you're going to have subduction, and that means one plate, and that's the oceanic plate, goes down. That's what subduction means. And when that occurs, okay, you're going to form a trench. That's the landform. And all a trench is going to be a deep, narrow valley. That's what and that's usually under the water, okay? And a trench is nothing more than a deep, narrow valley underwater. This is where you're going to get the deepest part of the oceans, Okay, so whenever you hear the word trench, you don't want to swim in that water. All right, the deepest trench in all of the world is called the Marianas Trench. It's 35,000 feet deep, 7 miles. Okay, 7 miles down. So I'm just going to write the Marianas Trench, created by subduction. Okay, the Marianas Trench is the deepest. 35,000 feet, guys. That's 7 miles. That's the same height that airplanes fly, but under the water. Okay, and that's in the Pacific Ocean, way out near the Philippines. All right, you're going to get volcanoes. So volcanoes are common. You're also going to get major earthquakes. Okay, so continental arc volcanoes, these are volcanoes on land, and you're going to get major, major earthquakes. And real examples on Earth are like the Andes Mountains in South America and the Cascades. And if you remember, you identified where these places were early in the year. Finally, you can have oceanic convergence. Same thing's going to happen. You're going to have subduction. Now you're thinking, well, but wait a second, both plates are ocean. Right. Usually what happens is it's going to be the older plate that subducts. So the older plate subducts. Okay, because as it gets older, it gets cooler, and it's going to kind of sink into the earth and get a little more denser. So the older plate subducts, and once again makes a trench. And you're going to form this time island volcanoes. So all your island volcanoes form this way, and you're also going to have major earthquakes once again. So notice that earthquakes are a common theme, guys. Every single one of these formed earthquakes. Even back here at divergent boundaries, okay, you had earthquakes. Whenever plates are moving, you're going to make an earthquake, all right? And then real examples on Earth are islands like Fiji, all right, and the Philippines and Indonesia and Japan even. All these places have major earthquakes, okay, and major volcanoes. So here is an example of a continental oceanic convergence, okay? And here's my ocean plate, and here's my continental plate. And as you can see, the ocean plate, because it's more dense, you got to know that, all right? Because the ocean plate is more dense, so I'll write down here, oceanic plate is more dense than continental, okay? As a result, ocean plate goes down. Whenever you mix two things, and one thing is more dense and the other thing is less dense, the thing that's more dense goes down. So if I mix oil and water, the oil floats because the oil is less dense, the water is more dense. If I put a rock into water, other than pumice, okay, rocks are more dense than water, so they went to the bottom. And that's why he did that lab, okay? So as you can see right here, guys, the ocean plate is going down. And because it's going down, it's subducting, all right? It's going to go into the interior of Earth where it's really hot, and it begins to melt. And now that it melts, it gets super hot, and things that are super hot become less dense. So it's going to rise up. That heat is going to rise up, all right? That magma is going to rise up and burst through the crust, and that becomes a volcano. And right there, where you can see it diving right there, okay, because it begins to dive, that's going to create that deep, narrow valley in the water we call a trench. So you've heard of some landforms now, okay? You've got ridges, trenches, subduction, not really a landform subduction, but you've got an action that causes the trench. Okay, the last one is called transform boundaries, all right? And at transform boundaries, plates don't come together, plates don't split apart, instead they slide past each other. So plates are going to slide past each other, okay? Sideswipe is another thing that we say. And here, at a transform boundary, you're going to have neither crust being created or crust being destroyed, okay? So crust is neither created or destroyed. The only thing you're going to get at transform boundaries, okay, are major earthquakes. No volcanoes and no mountains are created. Okay, and this is where we talk about, of course, the San Andreas Fault. The San Andreas Fault is the most popular transform boundary. So at the San Andreas, what's happening is you've got lands sideswiping each other. All right, no crust being created, no crust being destroyed, but you do get major earthquakes. Okay, so this is a real example on Earth. So this is what is happening at the San Andreas. Sorry for jumping all the way up there. This is the Pacific plate out here. Okay, and even I think it says that, or it says Pacific plate right here. And here's the North American plate here. And what's happening is they're both actually going this direction. But the Pacific plate's the fastest moving plate on Earth. And so it's going so quick, all right, that LA, which is on the Pacific plate, is moving faster than San Francisco is going this direction. So as a result, in about, as I said, maybe 100 million years, LA and San Francisco will be neighbors. And then LA will progress and keep on going up towards Alaska. So every day, LA is getting a little further north, even now. But, as we said, 3 to 5 inches or 1 to 3 inches per year, something like that, it's moving. And it's going to get a little cooler and a little cooler. And eventually, LA Rams will leave LA and LA Raiders will leave Las Vegas and all that kind of stuff because it's going to get cooler and cooler and cooler. Okay? So that is it for plate tectonics for now, and then we're going to come back and we're going to spend some time here. Okay, so there's your notes on plate tectonics. Thanks for listening.